Hello, this is Mr. Huber. In this lesson, we're going to learn about solving multi-step equations. Recall the process for solving equations, and we're going to see these various steps come into play throughout the equations we're going to see going forward. Simplifying both sides of the equation, getting the variable on just one side of the equation, isolating the variable by using reverse order of operations and those inverse operations to cancel out whatever's happening to the variable, and make sure we do those inverse operations the same on both sides of the equal sign to keep the equation balanced. And always good to check the solutions. So let's see some examples. Right? In this first example, right, how do we simplify the side of the equation? Well, on this left side, we can simplify this by 8x minus 3x. Combining those like terms makes 5x minus 10 equals 20. And now we've got both sides simplified. We can add the 10 to both sides. So we add 10, and we'll get 5x equals 30. And we divide by 5 on both sides and get x equals 6. Get to check that, we plug it back into the original equation. 8 times 6 minus 3 times 6 minus 10 equals 20. It's going to be 48 minus 18 minus 10 equals 20. 48 minus 18 is 30. 30 minus 10 would be 20 equals 20, and that checks. Right? So we can always check, and when you do so, make sure you plug it in the original equation. We don't want to check by plugging into one of our other steps. Always plug back into the original equation that you were starting with. All right, in this next example, the first thing we want to do to simplify is distribute. Right? Distributing and combining like terms are our most common ways that we're going to simplify one side of the equation. So we have 7x plus 2x plus 12 equals 39. And then we can add the 7x and 2x together to get 9x. They're on the same side of the equal sign. So we're not doing inverse operations, we're just combining like terms. And then when I subtract the 12 on both sides, I get 9x equals 27. Divide by 9, and I get x equals 3. And again, we should check that back in the original equation. I'll let you go through the process of checking just to ease of time here. We're going to not check every one of these. Okay, but x equals 3 would be the correct solution. This equation, we're going to see a fraction, which you can distribute into the parentheses, or what might make it easier oftentimes is to multiply by its reciprocal. Since this is multiplying the whole side of the equation, we can simply cancel that out by multiplying by its reciprocal on both sides, because 5 over 2 times 2 over 5 becomes 1, and that just gives us 3r plus 4 equals, like that 10 over 1 if it helps, 5, 1, 25. And then I can subtract 4 on both sides. I get 3r equals 21, divide by 3 on both sides, and I get r equals 7. In the next example, we've got a variable on both sides of the equal sign. So we want to get the variable just on one side of the equal sign. Now in this case, you could add 2m to both sides, and you'd have negative 3 plus 2, which would give you a negative 1m. Or you could add 3 to both sides, and negative 2 plus would be a positive 1m. Anytime you can keep the coefficient, the number in front of the variable, positive, I think that generally is going to be where there's less mistakes. So it'll work either way, as long as you're doing the same thing on both sides of the equal sign. But I think it helps a little bit here to keep the positive coefficient, have a positive 1m. So that's how I'm going to do it. But if you did it the other way and you worked out the answer, you should still get m equals negative 8. So as you're doing these, again, if you're doing it slightly differently, that's often okay. If you're ever not sure, ask, hey, if the way I'm doing it, okay to do it this way, and we'll walk through it. All right, here, the 1/4 can be distributed into the parentheses relatively easily because you're going to get whole numbers when you distribute the 1/4 times 16 and times 60, so I would just go with that route. So 9x minus 5 equals 4x plus 15. And now I can get the x on the left side. I could subtract 9x on both sides, but again, I would have 4 minus 9, I got a negative 5x. I'd prefer not to have that negative coefficient, but if you do that, it should still work, as long as you do the steps correctly from there on out as well. You get 5x equals 20, and when I divide by 5 on both sides, I'm going to have x equals 4. This next problem we're going to distribute and simplify. Right? Remember, we're going to keep that in mind. That's our first step, and we're distributing a negative 2. So it's important to recognize we're distributing a negative 2 times y and a negative 2 times negative 5, which gives me a positive 10. Be careful with that negative sign when you're distributing. Then we're going to get 4y plus 10 equals 46. When I subtract 10 on both sides, I get 4y equals 36. And now when I divide by 4, I'm going to get y equals 9. All right, so keep in mind here, we distributed the negative 2 into the parentheses, and then we're combining like terms here. 6y minus 2y, they're on the same side of the equal sign. We just combine the like terms to get 4y, and then get that variable by itself. All right, so again, you can be practicing and trying these on your own and seeing how you're doing. And if you're doing that on these next couple, you may have come across a situation that's a little confusing. So let's see what happens here. When I distribute on the right side of the equal sign, I get 2x plus 10 equals 2x plus 10. And now I want to get the variable just on one side of the equal sign, so I'm going to subtract 2x on both sides. It actually cancels out on both sides. When I get the variable, it cancels out on both sides, and I get a statement like this, 10 equals 10, or if it was 8 equals 8, or anything that's always true. Okay, 10 is equal to 10. So when I get a situation like this where it's always true, the solution is all real numbers. Okay? You could take any number you want, and you could plug it back in here to the original equation. It's going to come out true and be equal on both sides. So when the variable cancels out on both sides, and you get a statement that's true, this will always be true. It means all real numbers. Every number will be a solution for that particular equation. This next example, when we distribute the 9, and we get 9n plus 27 equals 9n plus 12. And when I subtract the 9n on both sides, I'm going to see that it cancels out on both sides. Similar to the last problem, but now I get 27 equals 12. So 27 does not equal 12. When I get a situation like this where the variable cancels on both sides and it gives me a statement that's never true, that's going to be no solution. Okay? There's no number that will ever work for that original equation. No matter what you plug in here, it's never going to come out equal and make the equation true, equal on both sides. So two special cases when the variable cancels out on both sides. If it's a statement that's always true, all real numbers. It means every number is a solution. If it's something that's never true, it means no solution. There's no answer that will ever work for that situation. Before we solve some more problems, let's take a look at this beautiful fish we see here. This is actually the state fish of Hawaii. It's really beautiful. It's got a really unique aspect to it. This little spike kind of off the top of its head, and there's one that will come out down here. Okay, this particular fish, it almost never gets eaten by predators. Okay, because when it does, and the predator tries to swallow it, it sticks these spikes out, and as it's getting swallowed, that slits the throat of the predator and just kind of swims away. So it might look beautiful, but it may be a little deceiving. It's not really going to attack or harmful in any way, but it does defend itself pretty well from that. And why do I say that's a mouthful? Well, the name of this fish is quite a mouthful. It is the Humuhumu Nukunuku Apua. That's right, the Humuhumu Nukunuku Apua. And now let's see some more equations we can solve. We're going to write them to then be able to solve them. All right. So let's see what we can do here. For 14 less than 8 times a number is 3 more than 4 times a number. So that's a key piece to this, right? That's where our equal sign is going to be. We want to be able to point that out and then simplify by writing what's on the left side of the equation. So the left side is 14 less than 8 times a number. Okay, so that's 8x minus 14. 14 less than 8 times a number is. So that's our equal sign, is. And now on the right side, we have 3 more than 4 times the number. So the same number, so we're going to use the same variable, x. So 3 more than 4 times the number, so 4x plus 3. And now I've got an equation I can solve. Subtract 4x on both sides. And we get 4x minus 14 equals 3. I can add the 14 onto both sides and get 4x equals 17. There's a lot of room to write the work down below there, so we'll just get that. X equals 17 over 4. And you could write that as a mixed number or a decimal since it's exact, but the improper fraction is fine as well. X equals 17 over 4. Find that equal sign and write each side separately, breaking it down, make it a little easier, hopefully. Here, the sum of 3 consecutive integers is 108. So there's our equal sign, is 108. Now on the left side, the sum, so we're adding 3 consecutive integers. How can we write that out? Let's say the first integer is x. Okay, let's say it was 10. What would the next integer be? 11, which is 1 more than x. And then if that would be 12, right? We need to know the word integers. Remember, integers are whole numbers and their opposites. So 10, 11, 12 consecutive in order. So it's not necessarily 10, 11, and 12. It could be 50, 51, 52. Okay? It could be -5, -4, -3, but it's always going to be a number, then 1 more than that number, and then 2 more than that number, right? So the next integer would be x plus 1. And the one after that would be x plus 2. and we want to add those integers together, and it equals 108. So now on the left side here, I've got my like terms I can add together. That's 3x plus, we got the 1 and the 2 added together, 3 equals 108. I can solve that now by subtracting 3 on both sides. I get 3x equals 105. And then if I divide by 3 on both sides, I'm going to get x equals 35. Keep in mind, that's not an answer. What are the integers? Well, the x is 35. Then the next one would be x plus 1. And the next one after that would be x plus 2. So 35, 36, and 37. Those are the 3 consecutive integers. And if you add those together, you'll see that it comes out to 108, which is good to check and make sure that it makes sense. Now let's check out a variation on that last problem. It's sum of 3 consecutive odd integers. So odd integers, let's say the first one's 5. The next one would be 7. Okay, so that's 2 more than the first one. And then 9, that would be 4 more than the first one. So they're not in order 5, 6, 7, but 5, 7, 9. So our first integer would be x, and then we'd have x plus 2, and then x plus 4. And when we add these together, right, it says sum, we're going to get 189. So we can simplify this and get 3x plus 6 equals 189. And then we can subtract 6 on both sides. 3x equals 183. And when we divide by 3 on both sides, we're going to get x equals 61. And then 63 and 65, right? X plus 2 and then x plus 4. That gives us our consecutive odd integers. And if we add those together, it comes out to 189, so that's a good sign. Looks like we're on the right track. Our next one, perimeter of a rectangle is 150 centimeters. The length is 15 centimeters greater than the width. So the length is 15 more than the width, right? The length is w plus 15. The perimeter of a rectangle, perimeter, is 2 lengths. So we're going to have 2 times w plus 15 plus 2 widths equals 150, right? 2L plus 2W equals the perimeter. And the L, the length, is W plus 15. So 2 times W plus 15, which now I can distribute to begin simplifying this. I have 2W plus 30 plus 2W equals 150. And then I can combine my like terms. 4w plus 30 equals 150. And then I can subtract 30 on both sides. I get 4w equals 120. And when I divide by 4 on both sides, I get w equals 30. That's the width. The width is 30 centimeters. And the length is 15 more than the width, so that's 45 centimeters. And I could check that. I could do 2 lengths and 2 widths, add them all together, see that it comes out to 150, and I know I've got the right width and length there. One more here. A recreation center has a membership that costs $80, and if you're a member, then you pay $6 to play a game of soccer. So what would that look like? As a member, you'd pay $80 plus $6 for each game. Non-member, so I'll just put N for non-member. The non-member pays $10 per game. We want to see how many games it will be for the member and non-member to pay the same cost. Same means they would have to be equal. So you have 80 plus 6G equals 10G. Right? We're out the situation for each one, and now we want to solve and figure out what value of G would make these come out the same. So we have 80 equals 4G, and when I divide by 4 on both sides, I get 20 equals G. So 20 games is when the member and non-member would be paying the same amount. So you might be able to use that to analyze, do I want to be a member or not? How many games of soccer am I going to play, and which one might be cheaper, right? So these situations, you got to write something out, find where that equal sign is, figure out what's going to go on either side. In this case, write the member and non-member being equal to each other, or the integers, the odd integers, whatever the situation might be with the perimeters. Come up with these situations to write out, and then solve it the same way you would any other time. Simplify both sides of the equal sign, get the variable on one side, use those inverse operations to isolate the variable, find out what it's equal to, and plug those in, check your solutions, make sure your answers make sense as well.